Swayam Prabha. Digital India. Educated India.
Welcome friends once again to our NPTEL MOOC module on health economics. As I have already mentioned to you that this course is also counted as a faculty development program type of course. Once you enroll and certified after examination, you will be also receiving a certificate and equivalent to faculty development program. More interestingly, to this course is that this gives different units. Those are highly applied, yet gives the backup of its theoretical base, clarifying each of the directions. In this particular week, we already explained discussion on or we discuss on efficiency. So, precisely on health efficiency, and we have in the previous lecture in particular we started explaining the software, the application, that is DEAP software, data environment programming. So, let us further apply it and clarify each of the tools, that is the discussions. So, that is why this lecture is called practical on data development analysis. So, the learning goals in this case will be on CCR input, CCR output, BCC input and BCC output, and will directly derive from the package from the software. So, that the findings what extent can be useful, you can directly write your papers after listening this complete video. This will be precisely 20 to 30 minutes and will be very useful to you. So, in the previous lecture, if you remember, I have introduced about DEAP software. We also given you the instruction files. We also discussed about the output files. We specified in the instruction how to set the commands, and simply in the DEAP software we derive the results. Today, we will be or in this lecture we will be discussing. At this moment, it is on CCR input based models. There are mainly 4 results given in the output file. So, we will be emphasizing mostly on efficiency score, then summary of slacks, then summary of peers, peer weights and peer count, then summary of input output targets. Other is by firm results. Okay. So, we will discuss each of them, how results are derived and how they are interpreted. In our example data set, where if you remember, we discussed with 2 inputs and 2 output case. That was the example on nursing hours and medical supplies and its impact on inpatient admissions and outpatient visit of the 10 hospitals or 10 firms. Okay. So, this is where we stand, and there are 10 H or the DMUs or the firms or the hospitals are here, and the inputs are 2 inputs. These 2 are the inputs and these 2 are the outputs. Okay. And we are now going to use further and to interpret the results. Now, just see one thing, the very fundamental result we derive is the efficiency summary. Okay. And if you remember, we made the file called ccr1-instruction.txt, and the data file is ccr1.txt. From the data file we actually derived, and an input oriented DEA model, that is CCR-IN I mentioned. The scale assumption is of course CRS, constant to scale, and and slacks are actually calculated using multi-stage method. Slacks we already explained earlier in this basics. Now, I am just going to show you the basic result, okay, in the next screen. So, if you remember, I will just show you that file which I have opened. The file is my CCR1 hyphen ins dot instruction is the txt. This is the file name, if you can read. But within that if you remember, we mentioned about that data is stored in CCR1 dot txt. That means it's a notepad file. We have to specify the extension as well. Then the output is specified as CCR1 hyphen out. Okay. Now, other important instruction we mentioned is we need to specify number of firms. In our case, it is if you remember, just now I mentioned in our case there are 10 firms, and number of time period, it is only the cross sectional we are explaining, only one time period, since one is mentioned. Number of outputs are 2, number of inputs are 2, and so far as input and output oriented models are concerned, we have had it been in output oriented, we could have mentioned 1, but since it is input oriented, the code is actually 0. So, we have mentioned 0. CRS base, hence it is 0, and since it is a basic DEA model, multi-stage DEA, because multi-stage, because we are capturing the slacks, okay, which I have just mentioned. All right. So, why slacks? Because that optimized and accordingly we defined about Pareto optimality against the general efficiency scores. Okay. So, we will also clarify through the result once again, and hence it is 0 since it is a basic DA, but later on if it is in an output oriented model, we also require two stage frameworks. We will be taking the help of 4 as the code. Okay. So, this is done, and if you want to see once for your data set, this is what we entered already. Okay. This is the data set, directly the data to be entered in this file and to be saved as with the file name. This file name should be specified. Now, I am going to close these files as a basic instruction, better to close and operate. Now, DEAP and output file is also already mentioned. So, we have to simply specify the instruction file name, okay, and need to enter. And we know that this is our instruction file name is CCR1 hyphen ins. This is what we need to just enter. Okay. So, and we know that we get our output, okay, and output is already saved in our file, output file we already saved it. Okay. So, you just see how it looks like. This is what is a first table to explain in front of you, that is the total efficiency, overall efficiency or efficiency summary. You start with the efficiency summary. So, the first table we are actually explaining, I am just now using the main window to explain you. Okay. Here is my main window which I just derived, and here it is. So, let us see efficiency scores of all 10 hospitals are obtained. In the first case, first section, you just see till the 10, and their efficiency mean score is also mentioned. 6 of the 10 we are just highlighting those 6, that is H1, 1, H3, H4, H5, H8 and 9. These 6 are technically efficient, okay, since their score is actually perfect 1, and they are called efficient firms. Also, Farrell efficient firms, those are not accounting for the slacks. At this moment, it is not actually accounting the slacks. After accounting for the slacks, we will actually decide about whether they are actually Pareto efficient or not. Okay. For hospitals 2, 6, now concern here is actually for 2, 6, 7 and 7 and 10. Okay. The technical efficiency scores are actually less than 1, but positive. Okay. Hence, they are called inefficient hospitals or farms. So, we need to have a scope for it's utilizing its slacks, if you remember. Hence, we will try to differentiate Farrell efficient as against Pareto efficient firms. So, we need to these have scope for improvement. Okay. So, improve their efficiency or reduce their inefficiencies proportionately by reducing their inputs through the input oriented models. So, let us see what are there. So, for example, H6 H6 can improve its efficiency by reducing certain inputs to by 24.2%. So, what do you mean by this? So, you can see the just see at the back. So, we have already mentioned H2 is 0.615 and that means efficient. What is the difference as against 1? Okay. So, it is still cutting short of 1 for form 2 and form 6. Let us stick to at this moment we are explaining 6. Okay. So, for the 6 case, so that means the difference is actually 1 is the optimum score minus 0.758. So, this is precisely 24.2%. Okay. So, we can improve its efficiency by reducing certain inputs up to that is 24.2%. Whereas, in case of H2 1 minus, since it is 0.615, so it will be 1 minus 0.615, this is precisely 38.5%. Okay. And can actually, if you reduce the inputs by this percentage, this can improve its efficiency. And similarly, you can also explain for H10, okay, since they are the inefficient forms. Here the mean, the total efficiency score, mean score is actually 0.909. This is also called the whole industry, overall 10 industries efficiency, that means they are 90% efficient. So, 10% inefficiency is still there, that can be also improved by individual level improvement. Hence, the question is which inputs need to be reduced by calculated proportions. These input reductions or output augmentations, the total inefficiencies, I mean that is comprised the amount of proportional reductions as well as called it is slacks for those hospitals that cannot reach their efficiency targets or frontiers despite the proportional reductions. So, we are supposed to actually utilize the possible slacks, which we already explained the meaning of slacks in our earlier lectures. So, what are those slacks? We will just clarify once again. Basically, if you remember in the input output model or in the output oriented in the input oriented model or in the output oriented model, we target the frontiers. So, slacks represents only the leftover proportions of inefficiencies. So, that is after proportional reduction in inputs or increase in outputs, if a DMU cannot reach the efficiency frontier, okay, slacks are needed to push the DMUs to the frontier, that is still the target. Okay, through the slacks we can reach to the DMU frontiers. Here none of the efficient hospitals have any slacks, okay, and only for inefficient hospitals if there is any slack. So, inefficient hospitals cases are to be discussed. No efficient hospitals have any slacks. So, as I already mentioned, so even it is output oriented or even in input oriented case. So, Farrell efficient firms are, in that case all are actually Pareto efficient, since there is no scope for slacks to be utilized. Whereas, if Farrell efficient firms or hospital has any slacks, that means Farrell efficient score are actually lesser than that of the Pareto efficient. Hence, their Farrell efficiency or efficient is not Pareto efficient. Okay. So, I think I have already mentioned in the result window, not discussing. Our next table is actually on this. If you see this carefully, I am just going to show it once and I will explain from the slide. Okay, so, this is the one which we are actually explaining, and I will be also utilizing this for calculation. Okay, and after that we will be also discussing about summary of peers. Let us come back to the main window and explain once again. Okay. So, first clarification is that where the firms which are having efficiency score as 1 or they are the efficient ones, they do not have any slacks, hence parallel efficient is also called Pareto efficient. So, we will start by explaining these from the, as I already mentioned, from the firm 2, and now we are actually explaining slacks, classes. So, firm 2 case required to reduce its nursing hours by approximately 12 hours, despite the reduction. So, in the you can see in the top table is for output slacks and the bottom one is actually the input slacks. So, through the inputs we can able to actually optimize the outputs. So, hence through the inputs you can see the changes, 12 which we have already mentioned. So, approximately 12 hours is required to reach at the efficiency level for the firm 2. Despite the reduction in this input, it would not achieve efficiency. To achieve this, H2 should also augment its inpatient admission by 44.8%. So, its output has to be also augmented. Just input reduction cannot able to reach. Similarly, a similar situation we can also explain for similar situation, a different magnitude is given in H10, we can also explain that as well. H7, in the case of H7 you can just see 0, I mean input reduction is not required, is not it. H7 should spend, now you can see it is the second one that is clearly mentioned. H7 should spend 2309.19 around less for medical supplies. The first cases it is 0, so the second one is important. So, second we have emphasized. Third table if you see is called pure analysis. I have just show from the output table summary of peers, which is the basic DEA model gives. So, peer explanation is given. Now, peer is very important because we need to I need to stick to the main window once again through the slides. Peers are important not just because of the individual firm, it is also because of who else are actually competing with me. So, and how they are competing. It gives who are my peers. If I am not efficient, then who are my peers. If I am efficient, of course, I am the one and there are no peers required to be efficient. If I am not efficient, we have already mentioned that firm 2, that is the DMU 2 is not that efficient. Even 6, 7, even 10 are not efficient. So, in that case, but others are actually with their efficient score, if you remember that those are 1. So, hence 1 peer is 1, 2, 3 peer is 3, 4 peer is 4, 5 peer is 5, so and so on. But the inefficient firms have different peers, they are actually trying to compete the best competitors. Firm 2 if actually competing with 3 can be a more efficient. This is what is the meaning. Peer is the benchmarking for the best practice. Like in this case, they themselves has to be defined as their benchmark because they are the top one if they are efficient one. But in case of that is the case of efficient hospitals, they are competing with themselves, where in case of inefficient one, they have to actually be benchmarked with the better firms, right. So, especially here 2, 6, 7 and 10 need to benchmark the efficient firms. So, here which I have already mentioned. For inefficient hospitals, their benchmarks are one or many, especially in 6 and 7 you just see it is not just one firm, they are actually 2 firms together, they are actually competing. And yes, weights are different. Now, of course, you need to compare with weights, whose weight is actually higher. So, benchmark with 1 or benchmark with 2 or even 3. A benchmark for H2 and H10 are actually firm number 3. For 6 and 7 there are 2 hospitals, that is H1 and H3. You can just find it from here. Now, since as I already said pure weights are important. It is not just one where is being competed or confronting with. So, there are multiple competitions. So, weights need to be taken carefully. Okay. So, we will explain those weights. I think in our table you have already seen it, and you will also find out the same result and check. You just see, to become efficient, H6 and H7 must use a combination of both H1 and H3. Okay. So because we have already seen that because we have seen that 6 and 7 are having with the pairs H3 and 1. Okay. Hence, they are taking a combination of these weights of H6 and H7. Okay. H6 and H6 a combination of H1 and H3. How much of H1 and how much of H3 as a combination to be taken, it requires little calculation, and I mean, this calculation must be taken very seriously, to that is precisely called lambda, okay, and as weights, okay, and then only efficiency can be achieved. So, these are called lambda or weights obtained from dual version of the linear program. Solved to estimate these values. For example, H7 in our case will attempt to H7 will attempt to become like H1 more than H3 as observed from respective weights of H1 and H3. Okay. So, this is precisely with a value called lambda of 0.237 versus lambda of 0.38. It is already mentioned, okay, very clearly for so far as H7 is concerned. All right. Another one is called pure count summary. So, I am not going through that software once again. I have already shown it. This is how it is displayed. So, pure count means one is basically just the reverses against the pure which I have already said. It is basically how many is being referred. Okay. Number of times each form is a pure of another one. Okay. It represents the number of times efficient forms, that is hospitals, are actually pure to the inefficient units. Like 1 actually 2 times somewhere counted. Okay. In 1 is the efficient form, as I already told you, it is actually counted 2 times by another firms, okay, or 2 firms counted, 1 is their peer. Similarly, okay, a firm 3 is considered as 4 times. So, 4 firms actually consider 3 as their peer, whereas others are considered 0 because they do not have any competition, or they do not have pure count. As an efficient firms may also pure count as 0 if it is not pure to others. Efficient firm always pure to itself. So, on counting as pure, it is excluded. So, for example, H1 count pures of 2, that is H6 and H7. You can just cross check from the data, it is already given from the first result, not data, from the result, pure result. And H3 count pairs of 4 firms, that is H2, H6, H7, H10. Okay. Another result is given as called efficiency targets for inputs and outputs. If you remember, when we say targets, that means we are actually sticking to target analysis, which already mentioned, like this type of mapping we mentioned. Okay. Summary of output targets, and we need to also, here slacks are also important. Okay. And for each hospital, target input and output levels are given in the figure as a result of result from DEAP. These targets are the result of respective slacks values added to proportional reduction amounts. So, to calculate the target values for input, the input value is multiplied with an optimal efficiency score, and then slack amounts are subtracted as per the formula which already given to you. Okay, if you remember that formula, optimal score is determined, then from the optimal score we apply through the slack method and can be calculated. For efficient forms, target values are equivalent to their original input and output values. So, no need to calculate further. Here we are sticking to 2 once again. starting from their input to their output. So, for the DMUs in efficient 1, that is 2 in this case, the target for input variables in the CCR input oriented DA model will comprise proportional reduction in the input variables, okay, by their efficiency score of the DMUs minus the slack value. Slack value is important, as I already told you, so far as target is concerned, is the slack value. Okay. So, and the efficiency score is also multiplied in order to reach at the target. So, in this case we are actually sticking to the result. In our case is nursing hours as the inputs, and medical supply is another input for the hospital number 2. So, our target is actually, this is what is mentioned. So, here is our input, in that case is H2, okay. NH is our nursing hours, and the slack is actually of that nursing hours, okay. And for the unit, that is DMU is 2, okay. So, in this one we are actually using, if you remember, our the efficiency score for the 2 is 0.615. I am just going to show you, yes. So, it is here, I am just using another window simultaneously. It could have been also put in the next slide, but you can just check the efficiency score we calculated from the beginning, that is the efficiency summary. It is here at 0.615. I am again going back to this, and we will be using further, alright. So, the if you remember, we are using actually the inputs, okay, the inputs and the output, as we have already discussed the slacks case already, okay, that is in terms of inputs and in terms of also outputs, okay. So, if you remember, I will just go back slightly, and or in the same window I will just tell you, okay. So, here it is, okay. So, 12.034, and that is in the case of inputs as 350, okay. So, input table, if you remember, go back to the table and check the input respective to the DMUs, it is 350. So, by calculation we find that the target value is of 203.360, this is what is derived, okay. Now, you need not be confused what is all about the DEAP is providing you, this is actually provided very systematically, and now you will be convinced. Similarly, target calculation of medical supply, this is for the first one we derived, this is for HNH, is not it, right. So, we can also calculate for the MS, right. So, for the medical supply, you just apply the values. We already mentioned that this is 615 times, in this case it will be of 1200, because that medical supply, the input was of 1200, and in that case the slack was actually 0. If you check it from the table in my another window, I can just highlight for you if you are a bit confused. So, this is 0, is not it. So, it is slack is subtracted as a 0 in this case, 615 already we mentioned, hence the calculation, the target boils down to be 738.495, okay. Similarly, you can also calculate for the output targets, and the formula will be different, input target and output targets are different. In that case, when it is output output target based, though it is input oriented model, but output target. So, our slacks will be positive, is not it, as I told you in our theoretical explanation. So, it is positive, so the slack is actually added. Now, the output slacks has to be added, not input slacks, okay. For again for the medical supply MS. Now, we are actually referring to this, we are trying to find out this result, okay, and this is for HS, sorry, for MS, for NH and MS, okay. Okay, we are actually referring to 134. Okay, this one is for NH. Just make a check. First one is actually NH and second one is called MS, but this table is for MS. Now we started first part is this, where you can just check this is for NH. Okay, this is MS and this is NH. Okay, I'll just cross check. Okay, I am probably made a mistake here. I am just clarifying. When we are saying output oriented, we have mentioned about NH and MS in the input case. Sorry, but in the output there are two output targeted. If you remember from my starting picture, I have to show it to you quickly and I will come back. Okay, so this is what we have shown it. This is what I forgot. This is our first output, sorry, this is our second output. Okay, inpatients admissions and outpatients visit, right. So, I will just go back to that page and explain you, and hardly I will be taking less time here. Okay. So, input we have already explained. Now, the first output 1, Q1 and Q2. Okay. So, I have already shown to you. So, and the slacks are different and slacks accordingly we have mentioned. So, we have just added the slack with that output value. Okay. So, output value was 90 plus the slack, hence it is 134.812. Okay. And in the second case, that is the second output which I have just mentioned. So, this is basically Q1 and this is basically the Q2 which I have just shown you. In that case, in the second output its slack was 0. Okay. Hence, it is the same. So, that is the target based efficiency scores we explained. So, 4 items are there. The last one is the result also gives by firm wise, firm by firm explanation. It gives 4 items. 4 items it gives. The original value, the radial movement, slack movement and projected value will be also, you can, if you use it, these 4, 1, 2, 3, 4. Okay. And I am not explaining much since we have already consumed more time and maybe taken off in detail later. If you go through on your own, probably you can find out. So, each of the directions, like for form 1, then the next one form 2 and so on. So, form 2 for example, form 2 the efficiency total technical efficiency score was 0.615 and we mentioned as inefficient form. There is a need of course, there is a need of radial contraction in inputs to define as efficient. Rex explanations are explained as above already. Okay, we already explained, but radial movement actually more important, and especially its inputs based slack adjustments are very required. Okay, so we will be explaining this BCC input model. Then in that case we will be using the separate file accordingly, we will be using the bcc.txt accordingly, and I will show you in detail. I have though made it everything here, but there are simple differences. Just a clarification in this case, rest are more or less same. So, the data we have taken, okay, and output file we can mention, we used to follow these actually earlier, and 0 we take. Here rest are same except this, just see, since it is BCC model, rest are same. I need not mention more time at this moment. Whenever time permits, we may give more emphasis on this. Rest are more or less same. And what is this BCC? As I already told you, it is based on variable returns to scale assumption. Okay. Hence, there are differences than that of pure efficiency as against the overall efficiency and scale efficiency. Okay. So, and then another interesting aspect is that we used to get 0 value for the multi-stage simple DEA result, but in this case, since we are using increasing VRS model, so we need 2-stage explanation. Hence, we have taken 4 as the code, and rest are same, and accordingly you can follow. Okay. So, in our case, in our practical example, we will be providing this document to you for your exercise as well. whenever you register for it, and you will be having access to all these practical handouts. So, we are actually using CCR3 instruction file, but earlier we have mentioned here also in our DEAP page. Okay. So, rest we need to just open that DEAP file, and CCR3 output is created by DEAP, and rest result can be interpreted very clearly. Okay. So, we have been discussing the application of DEAP software. We have already calculated the input base models. Now, as I already told you just couple of minutes back, that the CRS based input model and its interpretations, its derivations, etc., how the result is shown. Now, we are discussing the BCC input model. So, how we did it, I will just show you quickly, then you can recall very quickly. So, the data which we have already shown you, 2 inputs, 2 output. Okay. And at this moment, since we are changing to BCC, if you remember the theory, that is related to your assumption. Assumption here is which is related to returns to scale, variable returns to scale. We used to have the CCR model where it is all about the constant return to scale. Okay. So, now we used to get the technical efficiency or the overall technical efficiency results, hence overall summary results we derived. But here we are going to discuss in addition to that is called pure technical efficiency and also the scale efficiency. So, how we entered, I am not going to operate further because I have already shown you here, and through my laptop you cross check with my previous slide. So, my text data which I feed it is again the same one, ccr1.txt, it is here. Okay. And my output now I actually changing because I wanted to show you a different result based on BCC. Hence, it is ccr 3 hyphen output.txt. This is the new file I created, and I am mentioning in my instruction file. Another change is that we are supposed to specify, it is a VRS model, rest are same. VRS model, VRS means it is over here, it has to be mentioned in 1. Second one important interesting aspect is that we have to discuss about either 1 stage or 2 stage. Since we are addressing the targets or through the slacks, so 2 stage calculation is required, hence we are mentioning as 4. Okay. 4 is the code. Rest are same since it is input based. So, our model is actually input based. Okay. For your memory, once again for your clarification, we have discussed 2 output, 2 input as per our data. Fine. So, this is what we have discussed. So, we need to carry out again the similar approach. I will follow again, and I simply write down my instruction file here, that is CCR3, and make sure that you are operating on the same folder, and also it is suggested not to open any of these txt file, make it closed and keep all those instruction file, text, the data file, then your output file on the same folder. Okay. And it has to be the same name has to be mentioned here, that CCR3 hyphen ins, that's instruction.txt, and enter, you will get this result. Okay, this is the first result, that is called efficiency summary. And one interesting part of this is that we used to get the CRS based estimation with the first form, the 10 DMU of the forms along with their CRS values, but now we are in addition to we are getting VRS and the scale results. In addition to that, third column which also identify whether it is following which kind of returns to scale, increasing, constant, or decreasing. IRS stands for increasing, dash stands for constant, and DRS stands for decreasing. So, dash means constant, the form which is considered to be the efficient one in this VRS model, they are considered to be optimizing their level and used to be constant. Okay. Whereas, and another interesting aspect is that since the DMUs are very less and we are following the VRS based. So, the production function hardly gets any options to actually find out the changes, okay, the major changes through the VRS framework. It requires more DMUs to be effective enough to find out the inefficiencies. Hence, in this setup it derives almost all the farms are efficient except one, that is 6. Okay. Hence, our concern here is to emphasize how 6 is made and what is the interpretation all about. The full form of everything is mentioned for your clarity. I am not mentioning much time. So, we are referring to H6 at this moment. So, BCC VRS efficiency scores are generally higher than the CCR, okay, and efficiency scores for input oriented models. More hospitals considered to be efficient using this this particular approach whenever we have more hospitals or more DMUs to be there. How scale efficiency is the third column which you have mentioned. How it is mentioned as scale, it is basically the efficiency score based on CCR model divided by the efficiency score of the BCC model. That means the technical efficiency divided by the pure efficiency is nothing but called scale efficiency. So, this is how the third column is derived. You can just see the values are nothing but the ratio, these divided by this divided by this is nothing but the scale. Okay. And you can just cross check on your own, and hence we derive the values, and this is how it is highlighted in this slide. So, BCC efficiency score, that is mentioned as theta BCC star, considered as a pure technical efficiency, as I already mentioned, whereas CCR is called technical efficiency or overall technical efficiency. Okay. That is also represented theta CCR. Returns to scale, the last column, as I already clarified, I think I need not emphasize much. However, one interesting aspect here, to calculate and assess the RTS return to scale, that is increasing, constant or decreasing, sum of lambda weights values are important. So, lambda value, where to get it? If you remember, I discussed in the CCR based model, and again this model also assumes the basic assumption of CCR. Hence, the pure weights are important. Pure weights we already mentioned and explained in the last lecture. However, for you, if the summation of lambda weights finally if it is less than 1, then that is called increasing rates of return. If the sum of lambda is greater than 1, then those particular DMUs is considered to be decreasing returns to scale or decreasing rates of return. However, the dash are actually called where sum of lambda equal to 1, and they are considered to be the efficient DMUs. Okay. So, again you just check the CCR input result. We discuss about those lambdas and their summations. So, how we did it? We actually cross check with their summation of those pure weights with their respective peers. So, especially for H6 and H7, sum of lambda is an addition to their respective lambda weights. Okay. Sum of lambda value of H7 particularly in this case, that is 0.237 plus 0.237 and 0.238. So, boils down to 0.275. So, and hence since it is less than 1 and it is interpreted as increasing returns to scale. And however, in 10 it is more than 1, that is 2.097. So, it is following a DRS function. Okay. These calculations are run behind DEAP, it gives the result only. In the BCC pure analysis, we can have the pure weights as well for the different pures, and the pure counts are also mentioned here. Okay. So, you can see how it is interpreted. I have already given the detailed clarity. I think no need to emphasize further. The lambda weights corresponding to these reference hospitals are mentioned, where inefficiencies are noted. So, lambda weight really matters, which particular one that is the peer is actually loading how much of weight is more. And here final words with the slacks and efficient targets, because we already clarified in our CCR model. For the sixth case, the output slacks, the value to be noted in input slack, there is no slacks, hence we are not discussing. In one case only, in case of output slacks noted for the sixth form, hence that is matter of interest for us. And to reach the BCC frontier, so output augmentation approximately 16, in that case 16 outpatient visits is needed to augment the output. That is the interpretation. And target formulation for inputs using formula is which we used to give it. You can just apply the same way which we discussed the CCR case. And here for the 6, you can just see by substituting the efficiency score, actual inputs and optimal slack values in above formula, that is for 6, we get these labels for output, and by substituting the value we get the exact values in the outputs, right. So, you just cross check. If you have any doubt, we will be happy to address it. So, for the CCR output model, we will create a new instruction file. Since input we discussed, similarly for output we have to define, but now you just mark that since output takes 1 as the value as output oriented, hence we have changed it 1. So, now and this is CCR based CCR. So, this has to be 0 then, rest are, and rest are, it is CCR based. So, 0 is mentioned here. So, it is not creating any problem. Rest we have to create this instruction file as well, and we can offer it and get the result accordingly. The technical efficiency scores remain the same as CCR input oriented. The results in the summary of the slacks changes a bit, since our approach is for outputs. So, explanation actually are the same. So, I am not emphasizing further. If you have any doubt, we will do it. Similarly, in BCC output, we are only supposed to change this VRS as 1 and output is as 1, since it is highlighted in the instruction page. Okay. So, and that 2 4 we have already discussed a couple of minutes back. So, it is, and similarly your instruction file has to be specifically mentioned for this particular operation. The technical efficiency score remain the same as input oriented BCC model, but however slacks change a bit. So, accordingly you can explain the slacks carefully by applying the appropriate formula. So, that is all. I think I have clarified everything to operate the DEAP, the efficiency scores and its interpretations, etc. I am quite sure that you must be happy to apply on your paper. So, in the next unit we will be discussing about micro and macro indicators of healthcare, health data handling package that is open source as well as licensed data or some. We will explain and we will give you hand holding of those data. So, to follow the lecture very clearly, we are referring this author chapter 2 and 3 for better reading. I think with this I must close here, expecting your feedbacks. Thank you.